Hey, thanks everyone for watching. Today's in the modern world, the data driven decisions are the key to the success for each enterprise organizations. And the modern day businesses are heavily rely on the insights that extract from the complex data set. The large language models are promising to revolutionize how we interact with the data, even the multimodal LLMs. However, we have to face the key challenges with LLMs are hallucinations. The hallucinations are the major ones when we start interacting with the LLMs, and then it's going to create kind of like incorrect or misleading informations whenever we are interacting with large language models. So to avoid that, to a bit of accuracy, we use prompt engineering, and we do a RAG with a different kind of RAGs and prompting. However, that's not solve the problem of hallucinations, and it's still we need to face a hallucination into the complex task. So today I'm going to deep dive in a session of the memory tuning for enterprise LLMs with the help of Lamini. So how uh, it's going to solve the problem of the hallucinations. I'm going to walk through into it. So let's understand so how this Lamini memory tuning is going to work. What are the challenges it's going to be mitigate, and how it enhance the reliability of LLMs. So let's go deep dive into the ones. The accuracy. So I know that the models with RAG, the accuracy is good. However, when you go into to enterprise ones, and it's gonna have a few of the issues, and it's take a significant effect on the reliabilities of our performance of our applications when we are having it. So let's say it's going to be RAG is going to solve our 50 to 60% of the problem, and 60 to 70% of the instructed fine tuning. However, still we need to face the problem with the hallucination, but memory tuning with LoRa. So we can increase the critical use case by 95%. So it's a kind of like training specific knowledge. So how we are going to train with the help of the specific ones. I'm going to deep dive into the technical approach of it. So let's involve like how a 95% of LLM accuracy, and it's going to be increased. So its approach with Laura, it has a specific precise facts into your model. Unlike the traditional methods, Lamini memory tuning optimize the zero errors on a specific uh, facts and methods. What it's going to do it right, it's going to do a kind of expertise. So it's embedding into the facts into your model. So it invoke your experts model to answer the query. Let's assume the user is send a query, and it's going to be a prompt, and the prompt is going to convert into a JSON format, because that's gonna, for large language applications, the JSON is going to be a perfect way to interact with LLMs. Then we have the try to take that one, and we try to invoke with the help of the function to interact with API call to LLMs. And we have during that process we have an evolution of that function as well, like how it's been interacting with the ones, and we take those fine tuning LLMs with the precise expert, and it's going to generate the response. Whenever if it's going to generate the response, it's going to invoke the mixer of memory experts. It means like whenever somebody asking like execute some of the SQL query into the simple prompt, and we fine tune with our LLM with the help of Lamini, and then it's invoke those mixer of expert and response to that. So I'm gonna go into the deep dive into how you are going to customize your LLM. So unlike the traditional prompt tuning, you create a data pipeline, you select your basic model, and you do the prompt tuning, and you are going to deploy it, whether it's going to be RAG, but it's going to be in managed by the Lamini. What's going to do it like? It's fine tune, and it's do the prompt tune, and it's going to do the augment of the data set. So and it's do the reinforcement learning as well on top of it, and then it's going to be deployed the way it's going to be there. And there is an interesting paper if somebody wants to read the how we have to rethink the LLM hallucinations. That's a key one to do that. So in my architecture today, so what we did it right. I'm gonna walk through the 95% of accuracy of LLMs, how we are gonna do a Lamini memory tuning. So the architecture diagram is going to be for enterprise application. So how it's going to works into the ones whenever a user uh, ask any SQL query prompt, and it's take that input as a prompt, and with the help of like the function which we define, and it's going to convert into the JSON-L. Why into the JSON-L? So unlike the prompts which we interacting with the large language model with the help of like the APIs, they're going to issue with the kind of like the scalability was. JSON-L is going to give you a structure way to interact with LLMs, and we can do the more evolution on top of it, like how it's been interacting with LLM and how it's been responding to the ones. So the moment the LLM receive the JSON-L, the structure one, it's converted into the SQL query with the help of the SQL function, which we can do it into AWS, Azure, or GCP, and then it's use the libraries, which is like PyMySQL. It's interacting with our knowledge base and to the SQL, which we've been fine tune the LLM with our knowledge data. So what are the key advantages of doing that? I said like that high accuracy, so we can focus on to achieve a most significance ones to interacting with our database on top of it. And it's reduced the hallucination. It's 95%. It means that like it's going to give the more accurate information to the ones, and it's highly efficiency to do that. And the moment it's interacting with our SQL database, the ones, and it's retrieved with those memory expert, and it generate those responses back to the user with perfect the accuracy ones. This is how it's going to work into the enterprise ones. So most of the enterprises are always ask me those queries, right? So how I need to maintain my performance of my the SQL queries conversion. So we can have the performance matrix is going to be watch out. So how it's going to responding, and we can keep our bucket and capture those metrics. And every time we can do the reinforcement learning with the help of like a human or with the help of the machine, and understand this queries has been executing or not, and we can improve our performance the way we are interacting with LLMs, how the LLM is gonna responding, and we can use our evolution function to understand how what kind of accuracy it's gonna providing to us to do it. So there are interesting pages if you wanted to go through it, right? You can go through. So how it's gonna works, how it's reducing with the help of the memory tuning, how it's turning those millions of load adapters and selecting across the mixture of expert data interface of time. So we can deep dive into the memory tuning as well. And yes, and I submitted my job. You can see it, right? What are the jobs has been running, how the job is going to performing. That you can see into the playground. I'm able to log in uh, with Lamini one, and I can use my data set or model ID. So it's going to generate to me. So let's go and deep dive into the ones. There is a research paper. If somebody likes it, I'm going to provide those research paper to you, and you can see the advantages of Lamini one here. So let's go into our. So I run this notebook. So the very the key importance of this, uh, I'm gonna show it. So when I run this workbook, and it's been with the simple um, LLMs. I haven't done any fine tuning with the help of like Laura, and it's I use Llama 8 billion parameters to fine tune this. So it is a basic way how LLM has been interacting to the normal queries. So let's go into. I created those evolution pipelines as well. When I run, if you look at right, so when I run the data set, and it's trying to show me the results, stating that it's only showing the 30% of the accuracy. So it means that whenever you directly interacting with LLMs, right? So I can run and I can show it one more time. So the LLMs is going to take a simple query like what is average salary of player, right? It's might not able to give the accurate information who is the person and what could be the salary, who is number one into the list. So if you look at like it's going to give, even though it has been trained and vast on the knowledge of it, and we provided the data set to the LLMs, but when you are writing a SQL query to know with the help of the indexes on top of the table relationships, it's going to give us only 30 ones, because the reason for it, right, it has a higher error rate. That means, right, the most of the SQL queries which I'm showing to here, the queries is running between the, the LLM and the data SQL. It's gonna fail it because the LLM might not know how specifically it goes back and retrieve those queries, right? There might be the syntax issues. That is the reason for it. Now, what we're trying to do it like there might be the data cleaning issues. There might be different data types, columns issues. That's the reason it's may not able to give the accurate information when it's interacting with the databases. Now, what we are trying to do it right. So we are trying to generate the tuning data with the data of the LLMs, and I'm trying to see it right how it's gonna work with the new set of the data which you are doing it. So now I run this. I use a meta. So if I go back and see the results of it, right? So when I'm trying to load those queries again and giving this information again, still it's not going to give me the high accuracy one. Now let's tune Llama 3 with Lamini Memory Tuning, the one, and to write it right. So I'm going to give this kind of like instructions. You are in B analyst with 15 years of experience writing the complex SQL queries. What does it means? Like I'm instructing my Llama 3 LLMs, and trying to force it right. So telling like your analyst with has 15 years of experience. Consider this NBA roster tables for the following schemas. I define those schemas and write those SQL queries as a questionnaires to do that. So let's go into the when I submit that to tuning easily, and then I run the job. So whenever I run the job, it's gonna shows me the kind of a loss it happened. Like if I go to the here, you can see the loss actually the training loss into that one. So earlier it's been high, and it's gonna be low. So we can select our whatever the model which we wanted, and we can call the model and submit for the tuning. So it's gonna generate the model ID, and we can provide this model ID, and it started fine tuning the model, and it's going to show us like how it's been running and which kind of like GPUs it's been opening up, what port has been opening for us, and what kind of arguments which is sending to do it. And while the model is being getting trained, we can try to ask here and see like how it's performing, because the ideal way of like fine tuning the model. It's always should be a quantitative. The measure means like if you're trying for the couple of data sets and ask like how the model is performing, rather than wait till the end and see how the model is performing. So I always go with the results here and how it's been working into the mid, and try to see it like what responses it's providing to me, and how it's been, the model has been getting trained, what is the loss happening, and then further you can go and fine tune the model. So this is a way, and you can use your data set, whatever the data set you wanted to fine tune with the enterprise level. So I've given the model name here, and I ask the simple query now. So who is the highest paid NBA player? And the system says like the you are expect of analyst, and then it's follow this question into the one, and it goes back and write me the answer, right? So it's gonna be, the query should be like select the name salary from the NBA roster, where salary so and so in order, and replace with an integer with ones. So what happening here when you give the prompt, so we are making to the LLM to interact with the database the proper SQL query. Uh, so that's going to help us to get more accurate information. So this is a prompt is given by the user, and we convert this prompt, and the moment we pass this query back, right, to our SQL query engine, and it says like Stephen Curry, his highest paid MBA. Let's see, it's right or wrong. Let's go it here. So what are the data set which we have provided? The query has been generated, and then it comes back and said to us like this is the salary. So it means like it's converting the prompt into the actual SQL query, and it's invoking those experts agents to give the response back. And now we will gonna send each of the batches, and we're gonna train the data set with the golden data set. So what how it's gonna help, right? So whenever you send that, it's gonna improve the percentage of the query. So means like incrementally we are trying to make our llama tree with the SQL one. Quantitatively it's gonna improve our results. Now it's gonna give us a 70% of the accurate results to do that. So it's gonna give the average salary of the for player in NBA, it's gonna give you the more accurate query to us from NBA rosters to the ones, and improve the LLMs ones. Like so, we generate more, we generate more data into the ones, and we train the files with the queries to ones. So it means like we are trying to generate more data and trying to create a more kind of like a training to our LLM model. Here it's llama. So it's what it's trying to do it, right? When the more data is going to comes it, right, it's going to remove those duplicates, and then it's going to keep the valid queries, and it's remove that null values the ones. So earlier when you says like higher rates, because that's where like it's give the 30%, but here it's gonna give more than like 95%. So we keep the more thousand data points into the data sets, and we can filter it out 364 the ones. Now the moment which if I run it, right, it's gonna give me the training and what are the queries which I run with the help of like the 10x limit, which I did. It's going to bring those details to me. And now I'm trying to see like how this data is going to work, right? How this data is being trained. The moment if I send it to training, so it's been trained, and it's been 62.5. It's been doing pretty well. And now, if I wanted to train one more set of the data, that's what incremental way you have to train your model, not like one way. You said you give the huge kind of a data, and now this model is performing. So if you see it like it's outperformed now, the model accuracy is increased to 87.5%. the more accuracy, and it saved the most of the ones. If I ask the similar query earlier, which is giving the more one, it's gonna gives me the more accurate information to it. Like it's gonna gives me all the details of the players who is ranked 1 to 10 is gonna help us to build it. But a kind of like fine tuning, if we have a huge kind of a data set, are we have a kind of like synthetic data which we generate and start fine tuning, then we can create an enterprise level of applications with the help of like the LLMs with accurate information. So now it's kind of the query is like 95%. So it means like it comes the query accuracy is like 95% from 30% to 90%, which we achieve, right? Mm, That's how we are using the fine tuning. So thanks everyone for watching this, and hope you like it. Just share it, thumbs up, and if you let me know what are the important sessions you wanted to hear from me. Thank you. Thanks for watching, and